Very good morning, all of you. Today, we are going to discuss the introduction of algorithms. So, basically, algorithms are core practical technologies of computer science. So, the main aim of this lecture is to familiarize what is the need, what is an algorithm, what are the properties of the algorithm, what is the need to study the design of the algorithms, and what are all the things we are going to study about design and analysis of algorithms, followed by how to represent the algorithm with pseudocode, followed by an example algorithm. So, the algorithm was first proposed by a Persian mathematician called A.I. Swarzmi in 1825. In 1825 AD. So, according to his dictionary, the algorithm is defined as a special method to represent to represent according to his dictionary, the algorithm is a special method to represent the procedure to solve the given problem. The algorithm is a well defined computational procedure that takes some value or set of values as input and produces some value or set of values as output. Hence, the algorithm can be defined as a sequence of computational steps that transforms the input into the output. So, every sequential steps need not be an algorithm. So, algorithm has to accomplish algorithm has to follow five properties. Algorithm has to follow five properties. Algorithm has to follow five properties. So the first one is input. Every algorithm should have either zero or more inputs. Zero inputs means that some of the inputs are internally specified in the instructions itself, and some inputs can be externally supplied. And the next one is output. So here output means at least one quantity of the output must be produced by the algorithm. And next property is definiteness. So which means that each and every instruction is clear and unambiguous in nature. For example, if I am having an instruction like add 5 or 6 to x, so here I am not having clarity whether I should add 5 to x or 6 to x. Such type of instruction should not be there in the algorithm. And followed by finiteness. So if we trace out the instructions of the algorithm, The algorithm has to be terminated after a finite number of steps. So means it should have a termination point, and followed by effectiveness. An algorithm instruction, each and every instruction should have some purpose and it has to carry out some operation. An algorithm which is definite in nature and effectiveness is usually called as computational procedures. Operating system is one of the example of computational procedure because it has the clear cut instructions what to do, and followed by every instruction is having certain effectiveness. And then we will discuss the areas which we are including in the study of the algorithms. So let us discuss the study of the algorithms. So in this we are concentrating on four things. One is the design of the algorithm, and the other one is validation of the algorithms and analysis of the algorithms, followed by testing of the program. So algorithm design is the technique what we are adopting to write the sequence of instructions so that these instructions will produce the output. The algorithm design paradigms, there are five paradigms which are called as divide and conquer, greedy method, dynamic programming, backtracking, and branch and bound. Each and every algorithm design paradigm is following certain principle, and these paradigms will be discussed in the future classes very soon. Next, implementation. So the algorithms can be converted into programs either by using procedural languages or by using optimal object oriented programming languages. Or in this implementation, I can make use of the recursion or iteration also. We know what is recursion and iteration. Recursion is the calling the by sequence of instructions by the name itself, and followed by the sequence of instructions or a repeatedly executed within a loop is called as an iteration. So next, how to validate the algorithm. So validation is whenever we are giving sequence of right inputs, legal inputs, the algorithm has to produce legal outputs. So the validation, this checking is done in two different ways. One is called as validation and the other one is called as verification. So validation is doing things right, whether all the instructions are serving their own purpose or not, we need to check. And then verification is all about doing things right, which states that when we are applying legal set of inputs to the algorithm, it has to produce legal set of outputs. All things set in a right place, and they has to work on according to their purpose. This is called as validation of the algorithm, and then followed by how to perform the analysis of the algorithm. This is usually called as performance analysis, because every algorithm has to be converted into a program and that program has to be submitted to the computer system for execution. So whenever we are talking about the execution on the computer system, because the resources are very useful, we need to optimize the resources. So the performance analysis can be estimated in terms of the resource optimization. We have two important resources. One is the computational time and the amount of memory space the program is occupying. So in the performance analysis, we are going to analyze the complexities of the computational time and as well as the memory requirement, memory occupancy. So here we are estimating the performance in two different levels. One is called as algorithm level, which is called as the priori analysis, and the other one is at the program level, which is called as post priori analysis. Algorithm level is whenever we have algorithm with 10 instructions, I can say that 10 units of computational time it is taking by occupying 10 units of memory space, because it is only the estimation. So uh, priori analysis is the performance estimation and post priori analysis is the performance measurement. So because we are submitting the programs to the system and we are measuring the performance, when we are giving the input and when it is producing the output, we record the timings of uh, each of these cases, and then we can measure the actual performance, actual time it has taken to produce the output. So hence posteriori analysis is called as performance measurement, and this will be done at the program level. When it comes to analysis of algorithms, it is only at the algorithm level. So design and analysis of algorithm primarily deals with the priori analysis, and then followed by the next one is how to test a program. So here testing is done in two different ways. The first one is debugging and the other one is profiling. So debugging means checking whether each and every instruction is reachable or not, it is doing its job or not, we will check. So debug the purpose of the instruction. Once it is once the program is debugged, then once the algorithm is debugged, then it is very easy for us to produce the error free programs. So once the error free programs are produced, then we can submit the programs for execution, and then we can record the timings of the program has taken, what is the input time, what is the output time. So when we are recording these timings, it is like maintaining a system book, the number of programs executed and the time of execution of each and every program. It will be very helpful when we are going for a batch of processing. And then we will discuss algorithm specification, how to specify the algorithm. So algorithms can be specified in three different ways. One is by using natural languages, and the other one is using graphic representation, which is called as flowchart. But flowchart is not feasible for all the programs, because we have complex programs. To represent all these complex program flow in a graphical representation is really not feasible. And followed by pseudocode. Pseudocode representation is an intermediate representation between the program and the natural language like instructions. So this pseudocode representation will be used to represent the algorithms. So in any algorithm we have some operations. So those are called as basic primitive operations, conditional operations, and sequential operations followed by repeat operations. The basic primitive operations like reading the input from the user, printing the output to the user, and carry out some arithmetic and logical operations kind of thing. And conditional operators, as all of us know, we are going to execute an operation if the condition is true. If not, we will execute another operation. And sequential operations also, one after the other, what is the next statement that is to be executed? It will be maintained by count increment, and followed by repeat operations. So a block of operations can be executed multiple times until a condition is met. So these are the looping operations we are going to have in the algorithms. So let us see how to represent the algorithms by using pseudocode. So here I am having to enhance the readability and interpretability of the algorithms. It is always recommended to write the comments in the algorithm. The comments are represented in double slashes, and followed by the blocks. The sequence of instructions in blocks are represented with open and closed parentheses, and an identifier begins with the letter, and data types need not be specified explicitly, right? And followed by the compound data types can be formed in terms of the records. For example, if node is a record, I'm opening the begin and close parenthesis here, I'm writing, and here I'm having two data types, just like student record, maintaining the student record with roll number, name, and other details. And here I'm maintaining a pointer to the node link, so which is pointing to the record type node, and followed by assignment of values to the variables, which is represented as variable. So assignment is always associated with semicolon equal to, and by assigning the either expression or some value. And here we can use true 2 billion boolean operations, which are called as true or false, to specify the condition is true or not, and some logical operators like and or not, and relational operators like less than, less than or equal to, greater than or equal to, and not equal to. We are using some looping statements like for loop, while loop, and repeat until loop. So here while loop is a entry condition loop, so hence I am writing while here, while, and checking the condition. If the condition is true, I am executing sequence of statements. If the condition is false, exit the loop, and followed by for loop. So here I'm taking the variable, and initially it is assigned to value 1, and value 2 is the last value. Up to this, here I'm using an instruction called as step. So step is to specify either the increment or decrement operations we are having. So from value 1, if the condition is specified, specified condition is true, then execute the sequence of statements and increment and check whether it is less than or equal to value 2 or not, and then repeat the statements again. So here one step is a keyword, and other step is used for increment or decrement operation. So the next one is repeat until. Repeat is a exit control statements, so in which we will execute sequence of instructions first, and then we'll check the condition. So unless and until the condition is false, it continues to execute the sequence of statements. And a conditional statement, like if then else, if is a simple if condition then statement. If it is if then else, if condition, if the condition is satisfied, then it is statement 1, else it is statement 2. So with this we can go, we have another statement which is called as case statement. So case, in each case we are checking one condition and we'll execute the corresponding statement 1. Like this, n number of conditions, n number of statements, else we are going to execute a default statement like statement n plus 1. And we can simply use read and write operations to read the input from the user and to write the output to the user. And there is only one type of procedure which is called as algorithm. It specifies the procedure. So every procedure should have the name. Usually the name should reflect the purpose of the algorithm, and followed by, if you want to give any parameters, and those parameters can be given with a comma separation. So here I have an example program which is having maximum of n given numbers. So here I'm writing the algorithm max is my program name, and a is an array of size n, where n is the index value. And initially I do not know the maximum number, so I am assigning my result here, result to the first element, and from second element onwards. So I is also another variable. From I to n, I am checking all the remaining elements with a of 1, and whichever is the greatest number, that number will be copied to the result, and this will be repeated for all the numbers up to n numbers, and finally I'll be getting the greatest number that is copied to the result, and that result will be returned to the programmer, right? As I said, um, so this is how the algorithms can be written. So here we have an assignment: design algorithms for problems which are already you have practiced in the C programming lab. So practice for all those algorithms. If you have any queries, you please post below. And thank you for watching the video. Please share your feedback. Thank you.